Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list topic and pattern was reversal pattern. Previously we have solved how to reverse and how fast and slow pointer along with reversal technique has helped us solving problems like palindrome linked list and maximum twin sum of a linked list. Now in this video we'll see how to reverse linked list but from a left node to a right node, means the number of nodes will be given to us. So let's read the problem statement. As we already know कि we have to reverse it because the question itself says, so definitely for the optimized approach we have to apply that reversal logic. But let's see the constraint. The constraint says the number of nodes will be 500. It is very small, so definitely linear solution will help. And anyhow in linked list solution we mostly solve the problem in linear approach only. But the thing is 2n, 3n, 4n type of solution becomes brute force, and exactly n by 2 becomes the optimized approach. So in this problem what we have to do, let's see. Suppose we don't know how to reverse it, but we have been given a left and the right pointer. So it means left means from second node, right means fourth node. So this much node we have to reverse such that after reversal the linked list will look like this. But how is it possible? Suppose I don't know how to reverse linked list. So what I will do, I will read the original linked list, okay, and I will put values in my list. Suppose 1, 2, 3, 4, 5, 6 and done. Now from this node to this node, so can I say left minus 1 index to right minus 1 index? Yes. So from left minus 1 index to right minus 1 index, I have to revert. So what I will do, I will apply the 2 pointer logic here to reverse it. So after applying the 2 pointer logic, this will become 4, this will become 2 and this will become as it is. How I did? Left pointer will start from this and right pointer will start from this, or let's say j, and this is I. Correct? So I'll just swap the numbers. Once done, I will do I plus plus and I will do j minus minus. Correct? So next swap, done. So in the linked list, so we have reversed it. Now what we will do, we'll again start like we have the head pointer, right? So we'll make a new alias called current, and from current again we'll start, and one by one whatever value we have there in the list means 1. So I will put here 4, I will put here 3, I will put here 2, I'll put here 5 and 6. Can I say it has been reversed? Yes. But what is the time complexity? Time complexity will be O of n because we have read the values and inserted in the list first. Now another O of n to read all the values from the list and insert or overwrite in the linked list. So O of n, 2n time complexity, correct, and space will be O of n. Means for we have taken this extra list to insert our values and swap it here, right? Correct? Yes. So this was the brute force approach. Means in the linked list, if we can solve the linked list without using extra space, that is called in place linked list solution, and that is what optimized solution. But before going to that, let's see the code for the brute force approach. So this is the code we have discussed. First we will create the list and make a alias current. One by one, like until the current becomes null, we'll keep on reading the values and we'll put inside the list. Once done, now we'll start our I and j pointer from left minus 1 and right minus 1 until they become equal. By using the 2 pointer concept, we'll just swap it using the temp variable. Once done, again we'll start our current from the head and we will read all the values from the list and put in the entire linked list until the current becomes null. So O of n to read and write in the list, and O of n by 2 basically here to swap, or exactly not n by 2, but we can say this, like how far we are running this. Can I say from right to left? So difference between right to left, and that to half of it because you are using 2 pointer approach. Correct? So it can still be negligible, but depends on the constraint. The constraint says left and right can go till null, like n. So what if you have been asked to reverse everything? So in that case, so this while loop will run for exactly O of n by 2, right? So exactly O of n to read and write in the list, n by 2 to revert in the list, and further O of n to read from the list after revert and overwrite in the linked list. Correct? So nearby 2n plus n by 2. Can I say 5n by 2? It is linear only. But multiple times we have solved. Means in multiple iterations. And space wise also we have used extra list. So let's run the code. Definitely it will get passed, but it is brute force approach. After submitting this, let's see how can we think with optimized approach, means using exact reversal code, because the question itself asks to reverse. So what is the in place logic? If you are following our playlist, then definitely you would have covered how to reverse linked list, correct? So from this to this we have to reverse. So can I say whatever node we have to go, means 2, correct? 2 we have to revert. So I will be standing here. If I will be standing here, okay, and I know I have to connect this to the last node. Last node means when you will revert this, you know in the previous node, means with the help of current node you reverse, and previous node always points to the last node of the whole linked list, whatever you reversed. Can I say that? So idea is very simple. Let's erase this. I said this, let's name it previous left. Done. This, let's name it current. Okay, you will keep on moving your current, and your previous will point to this. Can I say? So I can say yes, this has been reverted. Done. This has been reversed. Your current always goes out of this and previous always points to the last node. Done. Now can I say if I am somehow able to connect 1 next to 4 and 2 next to 5, I can say it has been reversed? Yes, correct. Very good. So before reverting, we should have kept a track. So let's say we call this left node, means leftover node, correct? So previous left, if we will connect this next to 4 is nothing but previous. So what we have to write? We have to write previous left dot next. We have to connect this with previous. It means 1 next has been connected to 4. Can I say that? Done. Now 4 is connected to 3. Yes. 3 is connected to 2. Yes. And now we want to connect 2 to 5. Can I say that? So we have to connect 2. So 2 is what? Left. So left node means leftover node dot next means 2 dot next. We want to connect this with 5. What is 5? Can I say current? Yes. So if we will connect 2 dot next to 5, I can say, what I can say? 1, yes. 4, 3, 2, 5, 6, reverted? Yes. But make sure the base case is ki what if your head does not exist? In that case you will return nothing. And also what if your left is also 2 and right is also 2? Means the question says from 2 node to 2 node revert this. So does it make sense? Means you have only one node and it says revert this. It does not make sense. You should have at least 2 nodes so that you can revert this. Correct? So for base cases you need to be very much aware. Okay? So now how we will do? First, so we will start a dummy node. So now what we'll do? We'll start our previous left node from here and we'll take left minus 1 jump, means 2 minus 1 means only 1 jump. So previous left will be standing here. Once done, we'll start our current alias. Okay, and with that theory means we will start our previous with null pointer. Now we'll save in next variable. Now we'll move our current dot next to previous, means I am applying the reverse logic. I'm not going to teach the reverse logic again. I will recommend you all to go and check that how to reverse a singly linked list. Okay, once done, we'll move and current will come here. Means current will point to 5 and previous node will point to 4. And after that too we have discussed only what in the previous dot left we have to connect our previous. This 2 dot next we have to connect 5. So where is our 2 dot next? So before connecting your previous dot next to previous, definitely your previous dot next was pointing to this, correct? So before moving this na, you can directly save it here. What? Okay, in your leftover node, left node, you have to save your previous left dot next. Okay? So you can do in 2 ways. When you started reverting this much part na, when you started your current pointer from here, you could have saved your left node there also. Or else after reversal also, before connecting to this, obviously 1 dot next was connected to this. So you can save it here and after that you can disconnect and connect it here so that you will not lose this part, correct? Once done, what you will do? You will connect this left dot next to 5. So now dummy, this all are connected like this, means you can say reversed. Now what you have to return? You have to return head, correct? But you have the track of dummy node. So you can simply say dummy dot. Now why I said not head but return dummy dot next? Because the question might have asked you to to reverse from left 1 to right 6. So now it would have become 6, 5, 4, 3, 2, 1 and your head is pointing to 1. So if you will return head, so 1 and null will get returned. But the code logic dummy is connected to 6. So when you will return dummy dot next, 6 will get returned instead of head. I hope you get it. So can we see the code for it? So this is the code. The very first idea logic is if left and right are same, do not need to revert anything, just return as it is, means your head. Or else create the dummy node and create dummy, connect dummy next to head. Initialize your previous left with dummy and take left minus 1 jump. So when you will start your I from 1 till left, not equal to, so it is automatically left minus 1 jump. Just keep moving your previous left to next. Once done, start your current from previous left dot next. Why? Because previous left dot next is pointing to exactly that head of the node which we have to reverse. Okay, so current will start from there. Now this much logic is the reversal of single leaving list. Okay, now once done, previous left dot next, which is nothing but previous left is here, dot next which is 2 will save in left node, correct? And then previous left we have to connect with previous. So that's what we did. Previous dot next, previous left dot next. In the example number 1, it will run because anyhow 1 is what we have to return and 1 we have not changed also after reversal. And after that we will return dummy dot next. Remember, we could have returned head also, yes. But in this case it will pass. Why? Because in example number 1, if you see, earlier also head was 1. After reverting also head is still 1. So if you will return, it does not break. In example number 2, so left and right are same. So our base case will itself return head. But let me show you by running this. If you will run head, it will still run. Okay. Now I will go and change some test case. Means in test case, I will write from 1 to 4, means now it will become 4, 3, 2, 1. So now if you will run 4, 3, 2, 1 and if you will return head, you will get 1 and 5. See, wrong answer. Why? Because your output is 1 and 5. How? See. So see, here the head is pointing to 1. Can I say? Yes. And now suppose we have to revert this from 1 to 4. Okay. And dummy node we have connected this. Let's say this is dummy. Correct. So after the reverse, can I say it will look like 4, then 3, then 2 and then 1, and as the head is pointing to 1, so head will point to this. So at the end if you will return head, you will get 1 and 5 and that's what you are getting it here, 1 and 5. But you have to return this now, 4, 3, 2, 1, and this is only possible if you have some dummy node connected to this. So at the end you will just return dummy dot next. So I'll show you in this code is instead of head, if you will return dummy dot next, so you will get the correct answer, which is 4, 3, 2, 1 and 5. See, in the example case number 3, 4, 3, 2, 1 and 5. So this is why we have to create a dummy node and it is important. So I hope you understood. Let me run the code for you and once done, yes, let's submit this. Okay. So this was the code in Java. I hope you understood. And without using any extra space, which is called in place logic. And here is a C++ code with a similar approach, similar logic, and here is your Python code with the similar approach and similar logic. So if you understood the reversal from left to right, then definitely you can mark the next question also as done from the reversal pattern of the linked list. So if you guys have understood and liked the explanation, please make sure to subscribe the channel and like the video. Or if you have any doubt or any concern, please do let me know in the comment section. I personally make sure to reply each and every comment in the comment section. And that's it. If you want to connect with me, I am available on all social medias like Instagram, Twitter, LinkedIn. You can connect with me. You can get the connection links in the description and the website link also in the description. That's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.